All right, so we are going to look at problem 47 analytically. Now, they do give us a graph, which means we should probably lean toward somehow doing this graphically. I'm just going to kill this whole screen. I don't need any of it. Okay, beyond that, without the graph, whether you guys physically work this or not is up to you, but whether you're working or not, I need you to pay attention and at least help me think through it. If we know that y is equal to tangent squared of pi x over 6, and then minus 3. If we solve this analytically, the first step is to isolate what? Anything with an x in it is what we want to isolate. And then beyond this, we're looking for the x-intercept. So what should I plug in for y? 0. So if we do this, let's see. I'm going to rewrite it. I lied. If I just pretend there's a 0 here, what's my first step? I'm going to add 3 to both sides. 3 is now equal to tangent squared of pi x over 6. Okay, now what? Okay, I'll do the right side. It's tangent of pi x plus 6, or over 6, I'm sorry. And I've just taken the square root. What's this? What happens over here? Love what I heard Red say. Loved half of what I heard the other people say. The plus or minus matters. Okay, right off the bat, are there places on your unit circles that hopefully have all the tangents on them where tangent is positive or negative root 3? Where? So I heard pi thirds, and I'm going to clean up this answer in a second. 2 pi thirds, 4 pi thirds, and 5 pi thirds. Now, I noticed something just by these numbers, and you probably notice it if you're looking at your unit circle. These work nice together, and these work nice together. What's nice about them on the circle if you look at pi thirds and 4 pi thirds? They're pi away from one another. So my very first instinct, instead of just writing x equals, and this is just kind of like cheater math right here because I just wanted to make sure we can think about it, my argument isn't x. What's my argument? Pi times x over 6. So this is a good thought, and I'm certainly going to use it. I don't want to erase it, but I don't want it to look like this is like my real answer, right? This is just my scratch work to make sure we can see what's happening. So rather than x equals this, it's really pi x over 6 equals something. Questions before we do the next big part? Okay, I'm going to put these together. This should be pi thirds plus n pi. Do you guys agree? And I'm looking very specifically at these two here. Well, I want this for x. What do you want me to do? So interesting. You gave me the exact opposite order that I was thinking, but that's okay because it's the exact same thing. Interesting. Divide by pi n, multiply by 6. You're correct. Yeah, like I don't know why it felt so weird. Good job. You're right. Okay, this side, what remains on the left? Okay, let's think about this. If we distribute in, pi's would divide out. And notice I don't physically cross them out because we have to distribute it to both of them. And then I just get 6 over 3, which is 2, plus, now the pi's will divide out, 6n. Okay, here's the analytic approach. I think that we can probably, that problem took us, what, 2 minutes? Start to finish once we wrote it. How long do you think it's going to take if we use the graph? Yes, because when I do this, good question, thank you. I'm going to show a little bit of work here. Do you agree that this is going to be 6 pi times, or divided by 3 over pi? 6 pi divided by 3 over pi. They gone? What's 6 over 3? Yep. No problem. Okay. It's going to take 10 seconds with the graph. And we're going to see it happen. Let's check it. We got 2 plus 6n just now. I just want to look. And we would have got negative 2 plus 6n had we done the other set of 2, just so you guys know. We just didn't finish the problem. Does this thing touch the x-axis anywhere? Where? Okay. And then let's just look here. I kind of like this one. This one's a little bit harder to do with the graph. I was wrong. I was thinking it was going to be just as nice. Does this graph repeat again, you think? Like, we don't see it happening. But why would you ever think it repeats again? Because tangent, what about tangent? It's periodic as we go through it, right? So as we're looking at this, it is tough to tell where this one is, and I'm going to completely waffle on my previous comment. Unless we want to build this big graph, I probably wouldn't use a periodicity for this because it's less clear as we see this graph. Now, there is a bigger idea. 45, did you guys use a graph or did you do it algebraically? Okay, it's what I was hoping would apply here. And we may come back and visit this once we get a little bit more practice with graphing stuff and bigger graphs. But I want to look at this one because it's a much nicer graph to look at and get this idea across. If you solve it analytically, you probably get this. Now, what I notice is that this function, can I see a full period of it right now? Because we know what sine looks like. What's the full period of this? Like sine normally, it's this is one thing of it, isn't it? Like that's one period. I see it's, and we could shift it. It's just wherever I get back. I just think of that start at 0 and come up back to where I started. Can't tell if I'm losing you guys. Yeah. I'm going to draw it in my book. When I think of sine, I normally think of it as living like this. Like that's what it looks like. It starts here. And I notice that that's like this shape right here if I just start here and just trace that part of it. So I can recognize that that's, if this is what one period of sine looks like, we've just identified one period of sine. How big is the period of sine here? From 0 to 4. And I know that after every subsequent period, we just get back to the same spot. That's what it means to have a periodic function. So let's just check. If I know that there's a root here, then one period away, there's going to be another root. What's one period away from this? We said the period was how big? So if we go forward, do we hit another x-intercept? If I go another period away and I go 4, do you think I'll hit another one? So when I look at this graph, if I'm doing it, I don't think 3 plus 4n. I would write this answer in my head as -1 plus 4n. But are those the same thing? Yeah, if n is -1 on the red one, we get -1. And we see that we're going to get all the same numbers, just changing in. It's easy from the graph here, harder on the graph on the next one, but we have an analytic approach. Cool. All right. Thoughts? Okay, we're 2 now. We just did 47. 63 and 65. Awesome. 63 and 65, you guys have both checked, I think. Do you guys like legitimately check your answers? I would encourage you. We might be able to skip a ton of homework time as needed. I get arctan, I'm sorry, of -4 plus pi. Red. We're trying to work within 0 and 2 pi. Yep. -4. And I'm all goofed up here. Sorry. Where am I looking? Thank you. So there we go. I don't know why I'm looking there. Okay. As we look at this, the arctan of -4 is going to give you an angle. Now, if you calculate this angle, and you guys have calculators that do this, it can be hard to see that the arctan of -4, like what number it is. It's a hard thing to think of. Now, I do know that it's a number that exists between -pi halves and pi halves. Like, I'm sure of that because I know what the graph of tangent looks like. It looks like this. I can see it's going to be -4 is on there. So the plus pi part just works out because of where we are on the unit circle. We can add a pi, and we're still within a full period of it. Like, we're on the right side of our asymptotes. For these, I'm way less concerned with these on this particular problem. I'm way less concerned with the plus pi stuff for now, at least. If you can get to arctan of -4 and arctan of -4 and arctan of 3, I'm feeling pretty good with where you're at. We'll clean up the arctangent stuff when we do a little bit more identity stuff. Okay, if you can get to the -4, I'm going to be honest, I wouldn't say most. We work a lot of problems between 0 and 2 pi because it's such a common interval to work in. We're not going to go crazy with this one right here. If I can get to the arctan part, I'm okay with it for now. Cool. 65. Pi fourths and 5 pi fourths are nice answers. And then you should have arctan of 5. And my guess is if you only have arctan of 5 once, because the plus pi thing, again, not going to be our focus right now because I'd really like to have some time to get into new stuff today. After 65, what do you guys think? Or is that it? 85 and what? 85 and 87. Okay. You want to look at one of these? I didn't write it down, so I'm going to take whatever one you guys did. Cool. Are they hard? Here's a big question. This says, how many intersections are there? And they answered 1. Did you use only the graph, or did you actually find them? Okay, I'm fine with that. That's what it says to do. Cool. Do we agree there's only 1 point of intersection? They said it was an x equals 1. No, just 1 point of intersection. What did you estimate as that point? Are you sure? Use the graph to estimate or approximate. You're right. You're right. Okay, deal. Never mind then. 86, even if you didn't do it, how many points of intersection? I believe that. And on 87, that's a neat graph. Sine x over x? Huh. Consider the function. What's the domain? Ooh. I have a challenge for you if you said all real numbers. How many of you guys said all reals? What aren't we allowed to divide by? 0. What value of x makes us divide by 0? Why isn't there a piece missing? There is a piece missing, and they've even done it well. How big is a point? Does it have any size? No, like when we draw them on the page, they have a size, right? Calculators do not understand this. If you were to graph this, your graph would have a hole right there. But calculators, they understand and they treat holes like they're infinitely small because they are. It's a single point. We can't see it if we let technology graph it. There is a hole here. We just don't get to see it. Everywhere but 0 because it makes me divide by 0. Okay. The next one. Is there any symmetry? What kind of symmetry? I think there's y-axis symmetry. What do you think happens as x gets really close to 0? What does y get really close to? 1. Can somebody explain that statement to me? Because this is like this, I assure you, you're doing calc right now. You don't even know it, but you're doing calc. As I get really close to where x equals 0 on my curve, can you guys tell me, and if you weren't sure about this one and you had the answer, what y value am I getting closer to as I get really close to 0 from the left side here? And I get really, really close to it. I can't ever quite touch it because there's going to be a hole there. But do we all agree that as I go along the graph, I get really close to y equals 1 as I get close to x equals 0? What about from the other side? From the right, as I get really close to x equals 0, what y value do I get really, really close to? 1. Okay. You guys have just actually done a limit without knowing it. You've answered, if you see Mean Girls, the limit as x approaches 0, that's this. You're doing a limit as x approaches 0. Mean Girls, is that the right movie? Mm-hmm. Lindsay Lohan? Yeah. Okay. Yeah. All right. How many solutions does this thing have? 4? Why 4? Good. Love it. If we do -8 to 8, which is what they specify, this thing is going to keep waving. It's going to keep doing this just slowly. Is that true? That's not even true. That's not true. I lied right to your faces, but we'll get around that. If we look only from -8 to 8, Dolan, I like your statement. He recognized that it was this plus 2 pi, and then he said, but 3 pi is too big. So he's checking these answers and just comparing them and seeing if adding or subtracting 2 pi is still within -8 to 8. There are 4 total. Without graphing it, can you tell me what happens as we get really, really, really big in the x direction? Like really far out here. Does this thing keep waving just as tall forever? Does it get smaller? What do you think happens? I heard smaller. I heard it stays the same. Anybody think it starts getting bigger? As I go really far to the right, what x value am I getting close to? Like infinitely far that way. I'm approaching what as x? Negative or positive, depending on the direction that I'm pointing right now. That should be your positive, right? That's your negative? Goodness gracious, that's your, okay. So think this out. If I did the sine of 55 trillion pi over 55 trillion, like that's a big number. How big does sine ever get? No matter how many pi it is. Biggest sine can get. So we essentially could at most have 1 over 55 trillion. 1 over 55 trillion is pretty much what? I think this thing keeps getting smaller and it just starts oscillating, which is the word for this, and it just bounces less and less, and eventually it's just going to look like a horizontal line. although it really does bounce back and forth. Because x gets bigger and bigger, we're dividing by a bigger number. Cool. We're done? Bummer. Cool. All right. Have I collected homework from me? Guess I'm collecting this one. Basil made the decision for us. Cool. That's not a bad thing. Name on top. Number wrong. I'll look at him quick. I'll pass him back. Awesome. I'll come around, or Miss Sweet will come around and get them. And we get a little lesson today. Anybody just absolutely enamored with trigonometry at this point and you're super psyched about it? Do you like trig stuff? Better than what? It's better than what? Last year you weren't here for trig? Oh, I'm sorry to hear that. All right. So today we get to start a new section, and this section is pretty example heavy. Yesterday I did in Calc, I think I told you guys this, but I had a group work on the board, and we're going to try this today. One group that's doing work on the board is going to get to do it on the tablet, and you'll have the microphone with your group. Cool. Don't be shy. Nobody watches the math videos. Okay. So for this, we are going to define, we're going to define two quick formulas, and you guys have these on your sheets. I'm going to write them a little bit nicer. I do not have a I don't have a paper folding exercise for this one, just so you guys know. So we can do the formal proof if you guys really want to. I'm cool with it. But we're going to start 5.4. And 5.4 is pretty straightforward. It's like most things trig. It looks really ugly for a moment. And then when you take a step back and compare it to what's really happening, it's way less ugly than it's going to feel, I assure you. Okay, for this, we are going to be talking in 5.4 about two specific identities or formulas that we're going to use, and they are our sum and difference formulas. Now, you guys have these in your trig cheat sheets. I do want you to jot it down, but we're going to write it less than they do. So, these identities, again, it's not a threat. We can prove them, just so you guys know. And if anybody wants to, I'm totally down for it. But we have the following. And we're just going to start off with just the formulas. And that's going to be like our first piece here. Since it's the same thing here, I'm not even going to rename it. We're just going to write them. Now, can you guys on your trig cheat sheet, do you have the sum and difference formulas? They should all be together. And I'm just going to look at mine too. Hey, we do. They're on the left side. I think, unless I made a typo. What's the very bottom left? Even and odd for you guys? Oh, hey, well, you don't have them, and we're going to add them. I don't know why you don't have them. That blows my mind. But that's okay. Okay, we're going to add it in our notes or your trig cheat sheet. Ultimately, I think you should have it in both. Definitely on the trig cheat sheet too, though. So check it out. We're going to write these out as nicely as possible. So only thing that we need is we're going to let, and your book uses U's and V's, but I could use alphas and betas or thetas and zetas or whatever you want. U's and V's, how do you want me to write the angle? UV is the default in the book, but I can use alpha and beta or theta and phi. Doesn't matter to me. You want to use the angle? Which angles? Is it okay if it's U and V, or do you want theta and something else? Okay, so we're going to let theta and beta, which is just a capital B with a tail, be angles. That's it. Okay, so we have angles that we can measure, and that's it. So here we go. We're going to introduce a new sign here in a minute that's pretty awesome, and I think we've seen it. I'm going to change color for each of these. There's 6 total identities that we need. We're only going to write 3 because we have the ability to do that. So our first one, I'm going to put an asterisk so it doesn't look like a minus. We have the sine of theta plus beta. And I'm actually going to make this plus or minus. So here's where our 2 come in. The sine of theta plus beta or the sine of theta minus beta. Should I pick a different one other than beta so they don't rhyme so much? Change it. Up to you. I'm going to use alpha because I'm concerned that somebody's going to miss here and write the wrong thing. Cool. So the sine of theta plus alpha or the sine of theta minus alpha is what's happening here. So it turns out super chill. These things are real easy to use, and they make hard problems much nicer. This turns out to be exactly the sine of theta times the cosine of alpha, and then plus or minus, and we need the sine of alpha times the cosine of theta. That's it. Okay. Now, the plus or minus part, I just want to make sure, and it is, I don't think you would make the mistake here, but we're just front loading a little bit. If it is theta plus alpha, what sign do you think I use here on the actual expansion of this identity? Probably the plus. We're just going to use it. If it's sine of theta plus alpha, it's sine theta cos alpha plus sine alpha cos theta. Okay, top to top. We just stay consistent. Make sure it's on your note sheets also, just so you know. You don't need it for the quiz tomorrow, but you will need it for the test, I assure you. Okay, another one that we get, and I can already tell that because I made that comment, people are writing it on your cheat sheet, so I'll go ahead and just wait. That's a me issue. Top to top. If it's the plus here, if it's theta plus alpha, then when I do this, it's going to be sine theta cos theta, or alpha, plus, because I'm just using the top to the top. Or if it's minus here, I would use the minus here. Yep. Cool. All right. We have two identities on the board. Well, if we talked about the sign of a sum or the sign of a difference, which is what's happening here, the sign of stuff adding up or taking the difference of them, then we better talk about the cosines. So we also have the cosine of theta plus or minus alpha. Okay, this one is a bit different. This one, when we plug in to the sum or difference of a cosine, we're going to start with cos on both of them. Cos theta, cos alpha. Cos theta times the cosine of alpha. And then here's where we have one little weird spot. How do you pronounce this sign? Plus or minus, and that's not weird, and I think you guys may have seen this before. Have you ever seen this sign? And it feels so odd, right? And it is odd because we don't normally write it that way, but it is minus or plus. The order is specific when we say it. Like it's a different symbol, we say it different. And it turns out we're just going to say that this is minus or plus the sine of theta times the sine of alpha. We'll talk. I want you to, this sounds like I'm trying to talk you out of it. If the why is why does it do this, then the answer is a proof. And that's not a threat. I just want to make sure it's not a threat, but there's not a really easy, concise, oh, it's obviously because this. Here's where it's kind of bending your brain a little bit, and I'm okay with it. If I do the cosine of theta plus alpha, it's going to be cos theta cos alpha. What do you think I'm going to use here? Minus. We do top to top, bottom to bottom. So sine is nice because it's sine stays the same. If it's cosine, the signs change. That's why we use minus or plus and why it's even said differently. So if I did cosine of theta minus alpha, it'd be cos theta cos alpha, and then minus was on the bottom, right? So I do plus sine theta sine alpha. Cool. All right. The last two that we get, yeah, we can make this work as a one identity. Okay, this one, I'm going to be honest, it is way less common. Way less common. So here we go. We did the sine of these two, and I already started writing it, so everybody knew it was coming. We might as well do the tangent as well. And we're going to write this as tangent of theta plus or minus alpha, all the same. Now, this one, we are going to split into two categories because we're going to have equals, and there's going to be a version of it here and a version of it here. Because I can't, well, Let me think this out. Time. I'm trying to decide if I can make this work here. I think I can. We're going to see. And if we have to write it twice, it just won't be arrowed like that. They'll just be 1 and then 1. Okay. I think we can do this with just one line. So check it out. If we have the tangent of theta plus alpha, it's going to be a fraction, first of all. We are going to get the tangent of theta. And I'll use my arguments because I'm really bad about that. Plus or minus the tangent of alpha. All over. Ooh, and this one, you guys are going to have to help me decide. Before we write this, I need you to tell me, like, we'll check what I write down, and we need to see if this makes sense or not. Tan alpha, tan theta. This is my attempt to write 2 and 1. Who thinks that the way that we've written the plus or minus and the minus and plus, you feel like you can tell me what's going to happen?
Oh, okay.
So I'm getting a lot of like, oh, eureka moments, but no offense, but I don't think everybody in here probably has it. I think there's more people who don't see it than are being vocal about it. Okay, I really want to point to the screen, but I'll point with this. If it's a plus, what am I going to use up here? Plus. If it's a plus, what am I going to use down here? Subtract. We're just going to, we use this to keep it consistent, top to top, bottom to bottom, like we have been. This symbol is on top, then we use this and this. If this is what's written here, then we're going to use the bottom version. It'd be minus and a plus down here. We'll get, like, we'll see this one happening. Tangent, I'm not super concerned about, in all honesty. Okay, we're going to do one together as a class, and then I'm going to have you guys do a few together. Cool. Thoughts? Does this look like it's going to be awful, or is it going to be nice? That's fair. That's fair that you might not know. Okay, now here's the cool part. Without these, I have a challenge for you. I need an exact answer, not an approximation, which means this is not a calculator question. But you can look at your unit circles. I want, and we'll even make this the first example, which is super. Okay, I want on A, and I guess these are just going to be evaluate. And I'm just going to specify that I want our answers exact, which just means we're not going to do it on a calculator. Okay, I want an exact solution here. And here's my challenge for you. Do you want sine or cosine first? Okay. I want you guys to help me find the sine of, let me think this out, pi eighths. Check your unit circle. I'll give you guys like 30 seconds or so. The sine of pi eighths. I like that idea, Christina. Christina said it's just half of this. And I don't know that, like, you may not have been speaking to all this, but whether this was your thought or not, this is a really common thought. It's not on there. And you might recognize it's half of pi fourths. And if you know that the sine of pi fourths is root 2 over 2, you might think it's just root 2 over 4. It does not work. It's a circle. It's not a straight line. We can't just use a linear relationship. Can we do this on the unit circle? Like, it's not on our unit circle, right? So I think a natural reaction or a natural answer would say no, because pi eighths is between 0 and pi fourths. Now, you're wrong, just so you know, but you're wrong for a different reason. Like, you're not completely wrong. Pi eighths is not on your unit circle right now. We don't list it on the unit circle. Is it there? It's definitely there. Now, there's very few times where I would suggest that degrees might work better for you. This is one of those times. How many degrees would pi eighths be? Half of 45. So that's like 22. Ooh, I might have picked a terrible angle. Good news, I got a new challenge for you. We're going to come back to this one. We're just going to call this one B. We'll get there. I promise there's a reason. I was so excited about it. I mean, if you want to erase it, you could just call this one. But we'll come back. We'll hit this one later. I just don't think we have the skills for it right now. I got too excited. Let's do pi 12ths. That's going to work nicer. All right, same thing though. And my bad on that, guys. Sorry. Thank you for not laughing at me, making me feel bad or nothing. Okay, pi 12ths. What's the sign of pi 12ths? Same question, but we're going to go much quicker. But it's not on your unit circle. Would you agree? It doesn't show up as a point on your unit circle. But and this is just semantics, which just means the way that we use words to talk about stuff. Even though that point is not there, is there a point that corresponds with pi 12ths?
Yes.
Like, even though it's not highlighted, it's half of pi 6, so it'd be 15 degrees. Okay, for this, at least to start with, I struggle with one little part. Pi 12ths does not show up. If you want to think in degrees temporarily, I have no issue with it, but I would like you to make sure you get more used to thinking about the radians. If I can't find pi 12ths, that's a bummer. But what I think you guys can find for me, and I want you guys to actually find these for me, is I think that you guys can find me some way to add up or subtract two angles on your unit circle that give me, I shouldn't have written 30 here. What was this? I'm all over the place. Anybody notice that was supposed to be 15? What should you do when you notice it's supposed to be 15? Please let me know. I'm all frazzled here for some reason. I don't know why. This is 15 degrees. If you can find two angles that either add up to 15 when you combine them, or when you subtract them, they add up to 15, then we're going to be okay. Red says 45 minus 30 right off the bat. Do you guys agree that that gives me 15? Is that the only way to do it? No. How else could you do it? 60 minus 45 would also work. Could I do, I couldn't do 90 minus 60. That would give me 30. Are there some other bigger angles that we could do? Can we all agree that we should probably just pick one of the easier two that we find right away? I want it, instead of thinking 45 minus 30, I want it in radians, for now at least. So sine of 45 degrees minus 30 degrees is like saying pi fourths minus pi sixths. Okay, before we continue on, this hopefully highlights pretty quickly why we would ever want some indifference formulas. If I don't want to have to actually build the triangle, we need a way to calculate it. And if we can do each of these nicely, then this would be pretty straightforward and nice. They're long, but they're not terrible. We're going to expand this one out to the fullest extent while we work it. Using your identities, which unfortunately for you, you can't see on the screen, how does the sine of alpha minus theta, or theta minus alpha, whichever way we wrote it, work out? The sine of, and I lied, I will scroll up so we can see it. We wrote it as theta minus alpha, right? What's our theta in this problem? So good. So this is like our theta right here. And it means pi 6 is a what? Our alpha. Do we have a rule that says here's how we expand sine of theta minus alpha? It's sine theta times what? Okay, so check this out. This one time, we're going to write this all out. It's the sine of theta times the cosine of alpha. And then, big moment here, do we use minus or plus on this next part? Why? Yeah, because it was top to top, right? We're just using the same pieces. Minus the sine of what? Pi 6 times the cosine of pi fourths. Okay, there's more writing here than thought needed, I think. Before we continue on, questions. Your book has the exact same identity. It changes the order and the letters that they use. It's okay. I do sine, cos, minus sine, cos. Your book does sine, cos, and then they do minus cos, sine. They switch the order, but they're multiplying. It doesn't matter. Do we know these? Well, okay, let's knock it out. What's the sine of pi fourths? Okay, so let's see. We get root 2 over 2. And what's happening between this sine and this cosine? Okay, so I'm going to add parentheses to make sure that's clear. What's the cosine of pi 6? Okay. minus, what is the next thing that I'm going to write here? So I heard two different answers. 1/2. The sine of pi 6 is certainly 1/2. What's the cosine of pi 4th? Okay. I'm going to give you guys about 20 to 30 seconds. I want you to give me my exact answer here. Once you have an answer, I assume you and your immediate neighbor have the same answers. I'd love it if you check with somebody else in class to see if we get the same thing. I'm going to start working it here. We'll see if we all agree. We're about to identify whether or not we have some algebra gaps or not. What are you doing with the calculator just like Jesse? Ooh, love it. What do you think happens? Because that probably didn't help. So they don't add because they're not exponents, but I like where your head's at. If they're radical times a radical, what do we do? If you have a root 2 times root 3, it's just root 2 times 3. It's root 6. They just multiply into each other. The denominators would multiply. Am I wrong? I am wrong. Fantastic. Love it. I like my numerators, but what should be here? Huh, good catch. Was it on purpose?
No, was it not?
Nope, that's a typo. It happens. I have a cursive 4 now. Okay, looking at this. Here's our answer, and it's really dissatisfying. I'm going to make that look like a real 4. You might hate it. I just want to preface and let you guys know that later we're going to get square roots with square roots in them also. You're going to hate those also. This answer is perfect. This is the exact answer. You can get the approximation if you want. I don't want the approximation like 99% of the time. Our answers are all going to look very similar to one another. Okay. These are plug and chug. Do you feel the same? So I've given you the, rather than just making you come up and do the exact same thing, which you'll get practice when we have an assignment for it for sure, I would like you guys to attempt a different type of problem that requires the same tools. Cool. So with the remainder of class, we are going to be coming up to the board. I would encourage you to get these examples in your notes. We're not going to name what it's called yet, but I think that there's plenty of knowledge in here, and I've given you everything you need to be able to do this. But I want to try out a fun variation of this. So let's see here. I want us to work with the following. On A, I'm going to draw a couple triangles. So my first triangle, not to scale even a little bit, is this one. And then I'm going to say down here we have a wonderful alpha, just living the life. And I know that the side opposite from alpha is 4, and that the hypotenuse of this triangle formed by angle alpha is 5. Cool. The second triangle, still in this same problem, 2 triangles that we get here. The second triangle is over here, and it lives like this. And we're going to call this angle theta. And on this theta, I know 2 wonderful things about this. I know that the hypotenuse is 13, and the angle that's right next to this theta, the adjacent leg over here, we're going to say is a 12. two triangles. Okay, we'll split into groups here in just a minute, but I have two questions for you with regard to these two triangles. From these triangles, I want you to find the exact values of sine of alpha minus theta, and I want you to find the cosine of theta minus alpha. You need to use both triangles to get your answer, but that's the last advice that I'm going to give you, other than talk with your neighbors. These are right triangles. Yes, thank you for asking. Okay, we're going to do these up on the board, though, because I want to see what you guys come up with. Do you guys remember groups yesterday? Okay, I also don't, but we can get new ones. Check it out. You two and Davian, you're on the far board. Hazel and Beevils, you're on this board up here. You can write on the screen. And we have a couple groups here. Casey, no, we have a group of 4 now. Are we missing an extra person? 2, 4, 6, 8, 10? Nope. We have a group of 4 with you 4. And you're going to be on the back board behind Miss Sweet if she's kind enough to move, or you'll be on this board. I'm okay with either. Cool. I want you guys to work this. We're going to go over this at the start of class tomorrow. My hope is that you guys, well, hopefully we go over it today, but we're going to see what you come up with first. Do me a favor. There are markers. I had cups that they went in. Use a black marker. Anything that I need to add or mark or say anything on yours, I'll use a red one. You can write on this screen if you want. I'm cool with it. If you'd rather write there, I'm also cool with it.
I don't. No, this is good.
Control Z is fine.
Is the mic working?
The mic is recording.
Hello, guys.
What do we do first?
Casey?
A joke.
Okay, so
That's a 3.
We're recording our
Yeah.
process for you guys.
Yeah, we should all find our side. So yeah, 3 on
How
pad.
do you know that's a
That's a
three?
3.
Because it's the multiple
Pythagorean
thing.
It's a rule.
It's a rule.
And
So the
and then there's another one. It's a 12, 5, 13. I know that one.
wait, what are we doing?
12, 5, 13.
Guys,
Wait,
we're gonna
what do you
find the
This is
missing
what- this is
sides
then what
on
about
our
this one?
triangles. We got
It's a
3,
rule.
and then we got 5. You can use Pythagorean theorem, but Dolan said there's a rule.
There's a multiple.
I don't remember the things, but you know, Dolan does because Dolan's goated.
We're doing the sign one, right?
So we start with sine.
4
What,
and 5.
what do you mean 4, 5?
I don't get it.
Okay. Well,
Oh,
let's just,
okay. So we're gonna start with. You're gonna. I'm gonna put this down.
Right sign.
You got it. You got it. Leilani's writing.
Parentheses. 4/5.
Okay, 4/5 because we were using the first triangle with the with alpha and
But yeah, she's
then okay, and then we're also taking theta sine over cosine opposite and adjacent. Wait, what? No, I meant opposite and hypotenuse.
wait, no, we don't write time. We don't write time.
What is this? Nothing?
That's
No.
good, right?
Huh?
That should be good.
Yeah, but we don't
No,
need
it's gonna be
sine.
sine. It's gonna be-
That is sine.
So we're gonna have now.
That's
to
what
what?
sine is. We're basically plugging it in.
Hold on.
So
4/5.
we found
What?
sine
4/5.
of alpha.
Huh?
We plugged it in, and then we. I'm commentating.
The commentator.
And then we found
Now
sine.
use,
We found sine
12,
of theta, and then we put it in. You just plugged it in
minus
using the information, guys. And then, what is Dolan doing?
No, the formula. What
Hello?
is it?
It's really this one.
Oh,
Yeah, we
I don't
did
know
it.
what
what
sine
is the
that is.
formula?
Sign?
And then
Ah,
we're taking
it's
our
5/13
sum and difference formulas, guys.
times
so bad.
Oh my gosh.
times
Would you like to say anything?
3/5.
yeah, children, all the children.
Oh. Oh.
Okay. Do not do exam.
ASMR. I don't know if that picked up. Okay.
Now we just.
I'm kidding. Continue.
You're lucky we're on mic right now.
How are we gonna do anything? Okay, so then we can just.
So we're using
multiply
our
everything. Let's
using
multiply these
our
first.
sum and
Let's
difference
multiply these-
formulas
oh, let's
for
multiply
sine.
these first.
Let's multiply the fractions. So it's
The ones that we wrote
48
earlier.
over
And now we
65.
did the thingy, and now we are simplifying after we use the formula.
Well, that's what they are.
And Leilani's doing some epic math.
There's no
But then we have to change the. Oh, you're right.
Mm-hmm.
Okay, never mind.
There you go.
You know we still need space to do cosine, right? We'll just
It's here. We have 4 minutes. We have 4 minutes.
So we're probably only gonna be covering sine for you guys today, but you'll have the idea to solve
What
cosine
should
later
do?
if we're doing it right.
What happened to the 65?
You guys
This. Oh,
Yeah.
we don't need sine.
trust
Simplify it.
guys.
I need help.
We're still simplifying.
Divided by 5.
30 divided by 5.
6.
All right, we have 3 minutes. I want to look at something real quick. Let's look, because you guys are all starting off the right way. Some groups are showing more work and some groups are showing less work, but there's 2 groups that are showing work that have a fundamental flaw we need to discuss to make sure that we don't internalize this. I want you guys to look, and you've already done this. Tell me from the pictures on whether it's the board or yours, what is the sign of alpha?
4
The sign
fifths.
of alpha is 4 over 5 because opposite over hypotenuse.
Right, guys?
Here's my issue. If you know that the sign of alpha is 4/5, why on earth are you writing the sign of 4/5? You just told me the sign of alpha was.
Oh, yeah. So we did it right, guys.
You
We're
supposed
good.
to tell
We
us
are
how
okay.
you're doing it.
Can I ask questions?
Do you guys understand the difference there? Do you not see it?
Don't worry about it, guys.
Oh, that's fine.
So check it out. If you type
And
in
Leilani's
there's
drawing a
theta
very
base, that's
lovely
where the
doodle
sign
in the
of theta
corner.
is. I'll find that theta for you.
What
But
is
I
that?
don't think that
What?
this is
What
the
is?
rainbow.
What? That is not a
I think if you
rainbow.
plug it in,
What is that?
65 divided by 5.
That is
I don't know that.
13.
You don't need to do all the.
What? Yeah.
You already-
6
when you
13.
do this, you're getting the sign.
So that's our answer.
So rewrite it
So
now.
sine. Just rewrite this top thing right there. You just put equal. Put an equal sign. Just put an equal sign. And our answer for this one is 6/13, guys. So thank you for listening. I hope you figure out how to solve for the cosine, and maybe we helped you out or not. You know. Do you guys have anything to say?
5 goes into 65.
No.
Melanie?
Yeah.
Hi, good luck, ladies. Wait, what am I talking to?
It's Azerbaijan.
Hi, Addie. Hi, Bianca. Hello, YouTube.
What's up, YouTube? Casey? Stop eating. Okay. Anyways, good luck in your guys' games. And win for us. You guys got it. Love you
You know
guys.
there's gonna be 7 pictures of there tomorrow, right?
Oh. So Kachawa. How do we stop it? How do we stop recording?
So guys, how's the weather?
Wait. Go down. Just go here. Go here. Go.
Why are you pausing?
Wait.
It's this, right?
They can solve it
They can
themselves.
solve the second one.
Oh,
You have to go to
that's
the laptop. It's
Okay.
for whatever reason, I don't know why. Before you turn it off, tomorrow we're gonna pick up here. The boards will be erased. I would advise taking a picture of the board. Yours won't. You guys are good.
Okay.
Take a picture.
Oh.
We need to stop it for tomorrow, or when we need to start tomorrow. Start a class tomorrow. We're gonna be up the boards, okay? I might have a different group at the start of class tomorrow though to finish these well. Cool.
Best option.
All right. Homework tonight, I guess. Tomorrow we'll start class with a quiz, and then we'll go up to the boards, I suppose. Cool. Study tonight. I'm not giving you any additional homework.
Okay.
No cap.
Okay.
Peace.
Did I press the pause button?
Yeah.
Do I
Yes, ma'am.
press the pause button?
Yes, please.
Oh.